Welcome to this episode of Talk is Biotech. My name is Guru Singh. I'm the CEO of SciSpot.io and the host of this show. Today, I'm with an inspiring bio entrepreneur from the state of Alberta in Canada. His name is Harland Brandon. He is the CEO of Allos Bioscience. We will learn from him about his journey, his company's mission, vision, and much more. So let's start. Welcome to the show, Harland.
Great Thank you for having me.
Let's start with a quick introduction. Who are you? What you're all about?
My name is Harland Brandon. I recently finished my PhD in biomolecular science at the University of Lethbridge, which is in southern Alberta. It's kind of where we based our company out of for numerous reasons, but it's right in the kind of heart of the agricultural food belt in southern Alberta.
Very cool. So what your company is all about? What is Allos Bioscience?
So Allos Bioscience is a custom protein-based biosensor company. So we can make custom biosensors for a range of small molecules and detect them in solution in real time with high specificity and sensitivity, as well as because they're proteins, they're biodegradable. So it makes them easy to produce and also easy to dispose of.
Love it. Do you want to talk about your customer base? Who is the beneficiary of your technology? Do you offer it as a service or is it a product?
So the initial focus for our company is to sell a product of these biosensors as kits to either researchers in the field of carbohydrate research or to companies that have quality testing labs that are looking to measure different carbohydrates in solution through their processing of their products. So that's our initial focus. Long-term, we'd like to be more of a service company where we can actually custom design biosensors for anyone, for any target.
Very cool. And you said with the focus on carbohydrate, do you want to talk more about it? Is it like environment firms or waste disposal firm?
The first prototypes came about prior to Allos starting, and it was through a collaboration with my PhD supervisor and a researcher at the Agri-Food Institute here in Lethbridge. And they were interested in actually detecting some of these carbohydrates that there aren't really biosensors for currently. So it was kind of the collaboration between our two labs to actually develop these. And we realized that there was kind of a commercial potential for these, not just for the carbohydrate biosensors we developed, but utilizing the technology we use to make those carbohydrate biosensors to actually make biosensors for a large range of other small molecules. So our initial focus has kind of been the carbohydrates and that kind of food space for like the agri-food industry or biofuel industry.
That's very cool. So you talked about the use case in the food science company. Do you want to talk about the future? What type of use cases your biosensors will support?
I guess where we'd like to see this technology go is that it could be utilized for agri-food industry to actually detect, quality of their product over time. So the conversion of, the starting feedstock into, an end product. So, some of the ideas we have are like the conversion of malt into beer, be able to detect kind of the breakdown of those sugars over time, or the breakdown of pectin in plant cell walls, especially fruit, and breaking out into juice. But we have many other ideas where this could go. And there's probably a lot of other areas where people in the agri-food industry actually have detection needs that just have gone underutilized. And that a quick, easy to use kit like ours could actually fill in quite easily instead of having to take a sample and send it to some other lab or have to have all the equipment on site to do the analytical testing.
You're saying currently these companies have to send a sample for specific testing. What you're doing is you're empowering them with the toolkit so they can do those tests in-house in a more cost-effective way, right? So it has a great potential. Before we talk about the future use cases, do you want to double click on the technology and what are these biosensors for audience who is not aware of what is exactly is biosensor? Do you want to first tell what are these biosensors and why they are even important? Why are we even talking about them?
Sure. So biosensors are a two-part system. It has a detector and a transducer. So it can detect a small molecule and then transfer that information into something that can be read out, like an electrical signal, a fluorescent signal, or an optical signal, or a range of things like that. And what makes it a biosensor? There's kind of two kind of classes of these biosensors. A, the ones that bind to a biomolecule, or B, the ones that are made of a biomolecule and can detect something. And we kind of fit into the latter category where we use naturally occurring proteins that have a natural propensity to bind to small molecules in solution with that high specificity and high selectivity and sensitivity. And that kind of principle we utilized. It's a pretty well-known thing within the field of biochemistry to attach a fluorescent dye to a protein. But what really Allos has done is we have an upstream kind of process where we do the design computationally, utilizing several different computational techniques to kind of cut down that initial development time, because it takes a lot of trial and error usually. But what we've done is being able to cut that down into a matter of weeks rather than the years that it can actually take, and then produce these biosensors for anyone to use.
Right. What is proprietary here? Like, did you create these proprietary biosensors, and what is unique about them?
Currently, what our company is doing is we're licensing a patent from my former PhD supervisor, as well as some of the grad students in our lab, and a researcher at the research center in Lethbridge, that they've done to actually design the computational pathway that can be utilized to make these biosensors quickly. So the real kind of innovative technology we have is that computational piece. And all the biosensors that come out from that tend to be are covered by that patent. Very cool.
Very cool. What was your motivation to start a biosensor company?
I guess it was a perfect storm of different things right at the time this kind of came out. I was just finishing my PhD, and so was my co-founder. And we were looking for that next step in our career. And we were both kind of interested in the industrial, going to industry instead of academia. Right. Also, the province of Alberta had a program that was set up to kind of help take research projects from the lab into a commercialization potential with kind of a focus on that green energy, green technology. And that was the Green STEM program that kind of helped, or that was offered. It was it actually came about through the carbon tax a couple of years ago. So those two things, as well as our professor having this technology and us knowing the kind of potential of it and seeing it grow over the years, we knew that there was something there that we could actually take it to market. And it was just more, what biosensors does the market need? How could they fit into this Green STEM program? And let's take a kick at the can of this entrepreneurial journey. And it just happened to work out perfectly that we could bring them all together. And that's the kind of foundation of where Allos came from.
Love it. Love it. So do you have currently access to some lab space from the university?
That's a great question. So Allos is based out of the University of Lethbridge, specifically within the SimBridge makerspace, which is a kind of biotechnology, biotech makerspace. It was set up at the University of Lethbridge to help small companies like mine and some of the previous ventures that have happened at our university that weren't able to really get that traction because there was no place that they could actually, no bench space, no infrastructure. And it's a really high capital cost to really get into a biotech company. So the SimBridge makerspace has been quite revolutionary for helping us get off the ground. And we're quite thankful to the University of Lethbridge for actually, taking the initiative and seeing the potential that biotech will have in Southern Alberta. Specifically that we have, a nice focus on the agricultural industry in Southern Alberta, and that there's a really good potential for ag biotech here in our province.
Right. And speaking of barrier to entry, what major barriers to entry you faced while starting this company?
That's a very good question. I could probably talk on this topic for a long time because this is actually not even my first company. And my first company kind of hit those roadblocks that I was talking about with not having that maker space in the University of Lethbridge. And I think this time I've really learned from some of those first mistakes we made with that company a couple of years ago, as well as, now there's the infrastructure set up with like SimBridge that we can actually have a place that we can rent and do the research we need to do to take the technology from a research project to a commercial product. But I think probably still one of the major roadblocks for us is both me and my co-founder are scientists by trade. So jumping from there into the business world has been a very eye-opening experience and, at times quite challenging, but it's been a fun challenge over the last year, specifically because we're doing it in the middle of a pandemic at a small institution in Southern Alberta. But I think we're doing quite well for where we're at and this current circumstances.
Right. No, I think that's a beauty of entrepreneurship. You have to learn how to feel comfortable when you are uncomfortable, because you're uncomfortable all the time. So when you start a business, you basically do everything, right? You have to wear 10 different hats, and it can be really challenging, but rewarding too, because you grow as a person too. So what about like your journey? Do you want to walk us through about your journey to the entrepreneurship?
I took an interesting journey, I think. Maybe not too different from many other people, but as a scientist, I started with that kind of ambition of going to medical school. And I wanted to be a doctor, but I got into university, and I went to the University of Lethbridge for my undergrad in biochemistry. And I was doing the classes, I was enjoying it, and just kind of going along. And between my second and third year of university, I joined a university club or team, I guess, the Igem team. So the International Genetically Engineered Machine Competition. And I fell in love with it. I thought it was the coolest thing, doing biotechnology, this new field of synthetic biology, and then getting hands-on experience in a research lab, which is great. And then that fall, going to Boston for the giant jamboree, and getting to see all the different projects and just like how science can be, used for different companies or different like projects to like make new commercial products, and how it can actually help change the world, which is very inspiring to me. At the same time, I was actually able to join a research lab at the university under my current professor to do an independent study and research kind of as a student. So I was actually able to get in and do an actual research project at a really young age within my undergraduate career, and start to like really get into it. And I just kept working in that lab every year going forward from there. And then once I got to the end of my undergraduate, I went into the master's program at the University of Lethbridge to do biochemistry, because I just was so into science and doing scientific research, as well as I was right around the same time where me and a couple other friends from undergrad tried to make a company at the University of Lethbridge in synthetic biology, kind of taking some of those things we learned from Igem and just applying them to a project that one of my co-founders had in the neuroscience department to try and help make a biosensor there. And we hit many roadblocks then, because our university was still pretty young. They were new to like the companies and didn't have a maker space. So we just were like fish out of water pretty much. So all of those kind of like issues we faced, the university kind of took in stride and helped set up the next infrastructure for the next generation of people like us to kind of come with new ideas and create new companies. Because I think at this point we've had 3 or 4 spin-out companies from the Igem team at the University of Lethbridge. But they all kind of face some of those similar issues. So now we've kind of got, the infrastructure built up. The university is totally on board. They take no intellectual property from anyone that makes anything at the university, which is quite different than a lot of universities I've been told. So there's tons of benefits like that.
This is super interesting.
So I went into my master's program, doing a project that I still love, that I started in my undergrad, and I ended up transferring into the PhD program instead of completing the master's, just because I really enjoyed it and I wanted to see the project go to fruition. So that kind of went by, and got to later stages of my PhD. I was trying to figure out what the next steps would be, and that's kind of where right around the same time that the GreenStem project was announced in our province. So we applied just after the first cohort started, and we're kind of, got accepted mid cohort 1, start of cohort 2. So we're kind of officially a part of cohort 2, but we were quite excited to get the funding to start up Allos Bioscience that way and take this research project to the next level. And that's how I got to here.
I have been a fan of Igem. I think they've done a great job creating the next generation of bio entrepreneurs, right? When you hear about the projects they do, sounds so futuristic, but also it makes you believe that biotech revolution is on the horizon. So I'm a big fan of Igem. I'm a big fan.
Me as well. Me as well. I do everything I can to support it. I think as part of the university team as a student for 3 or 4 years. And then I tried to advise it for 3 other years. So I think I took part in like 7 years of Igem. We even have a high school Igem team at our university where we bring in high school students and they do projects too. And yeah, it's been very rewarding to see. I think we've actually started that high school team in, I want to say 2011 or 2012. And it's cool because some of the students that started in that Igem project then eventually came to the University of Lethbridge and have gone on to do great things past their undergrad and their graduate degrees. So to see people that get the idea for synthetic biology in high school and just run with it from there is an experience I would have loved to have, but I'm glad I could help others achieve that and be part of that.
How would you define Igem? Because I know it's more like they have chapters, regional chapters, right? Then they have this annual international thing. So like, how do you describe Igem? Do you want to talk about it?
So I describe Igem as a primarily a synthetic biology competition where you can come up with the coolest ideas and just take biotechnology to the next level. And it's got like two aspects: the learning in the lab and getting to experience, wet lab work and doing synthetic biology, as well as, and coming up with a really cool project, as well as the actual experience of going to the giant jamboree and meeting people and seeing just the enthusiasm around synthetic biology and some of the crazy ideas that people come up with and that, lead to new companies and just how they've progressed and over time. So it's, I think, probably the most eye-opening experience for any young scientist.
Right.
And I'm glad it's more of like an undergrad focused thing. Maybe there's some graduate students that are a part of it as well, but it definitely would help any undergrad really see kind of the future and, maybe steer away from the medical school angle like I did into the sciences and see the potential there that we might not be exposed to in high school.
Right. So how does it work? Do they send a kit for like editing, gene editing? Or like, do you have to submit your proposal and then based on that, they give you a gene editing kit? How does it work?
Good question. So the whole competition kind of uses the basic molecular biology principles, so using restriction enzymes and DNA, and kind of has a Lego-like kind of approach to it where you can like put different bio bricks together. And that's kind of what they refer to, the individual genetic pieces that you can use to make up gene circuits. So that kind of Lego-like effect can be used to build up bigger and bigger constructs. And what they usually do, I'm not sure if they're still going this way. It's been a couple of years since I've been part of the Igem competition, but they used to send you out a whole like kit plate that would have, a 96 well plate with a little well with lyophilized DNA for each individual part, or at least the ones that they would send out. So you can either do that and like build up from those basic parts, or you can actually just do gene synthesis of what you design as a construct with, fitting those kind of basic building block kind of criteria. So you make sure it could be put together with other pieces down the line.
If someone want to be the part of Igem community, what would you advise them?
Definitely, I guess it depends on what university you're at, but I'm pretty sure most universities at this point have an Igem team because the competition keeps growing every year. And it's more like every year, more teams from Europe, North America, South America, Africa, Asia, everywhere. There's teams from everywhere. It's great. But yeah, I think just looking up to see if your school has ever done Igem, and then trying to reach out to see if they have an open call for joining the team. I know at our university, every year we usually send out, the former team students go to class early in the year, like January, February, and kind of pitch, this is Igem, you can join the team, and try and recruit people that way. Like, it sounds like a science competition, but it's not just a science competition. Like, we've had people from the arts department on our team before, from economics and business students, because there's multiple aspects of it all. Not just the science, but like the ethics of it. We don't have a large philosophy department at the university, but we've always wanted to get more philosophers on our team because some of the implications of some of this technology has major ramifications on the world. And I think we've tried to explore that with at least 2 projects at our university. They kind of have looking into different genetic elements, specifically one, I guess I'll give one example. We did a project that utilized an RNA element known as a pseudoknot, which can cause frame shifting. Basically, that can change what the protein is produced because it can shift from one frame to another and lead to a different protein produced after that. And we weren't sure if if you did that or had enough of those, like in a sequence, that you could maybe produce a protein that can be toxic, or like, one of those proteins that, no one should make, like, bioterrorism type thing. And we worked with some of the sequencing companies to see if they would actually be able to pick up, some of those things. And thankfully they were, but it was a very interesting exercise, not just in like the science of how things work, but also, what is the potential downfalls of what we're making and how could it affect the world negatively. And I think from that, we were actually able to get a security commendation from the FBI at that year's Igem competition. And that was a really crazy thing to us. As Canadians, we aren't affected by the FBI that everyone in the US is, but still to get we know of the FBI, so getting a award or a commendation, I guess, from the FBI was a very humbling experience.
Right now, I think biology touches so many different fields. And I think we need more different perspective in biology. Like biotech shouldn't belong to people just in biotech, right? It's very important that all walks of life, like people from different domains, participate. So I don't have to know all the tools and techniques of molecular biology to be a biotechnologist. So I think that's probably Igem is focusing on, to democratize biotech, right? So we get different perspective and create something amazing to make this world a better place. So
I fully agree. And I think it's only going to be getting better and better as gene synthesis gets cheaper and biotech just continues to grow, especially if all the governments of the world start to see the benefit of it. And I'm pretty sure a lot have invested pretty well into it. I know our province has invested into it quite well, and it's very promising to see the change that just I've seen from starting my undergrad and seeing the biotech community space within Alberta and how it's kind of grown since then, specifically in the synthetic biology space. So
right. What do you think about the future of biotech in 10 years, 20 years? What do you think we have to do to bring more people in the industry?
Oh, that's a very good question. It's it's probably one we could spend a whole podcast talking about, just because there's so many cool avenues that it could go. I think probably the biggest things that need to happen in the next 10 to 20 years is major advances in plant biotechnology and fungus biotechnology. I think those are kind of the two big ones. The things that plants will be very revolutionary for how things can go, just because, plants can be helpful for the agri-food industry and helping really push forward, making sure we can feed everyone in the world. Right. Whereas fungi have this really great ability to break down things, right? And I think one of those projects that I always keep thinking about is, how do we fix the issue with landfills, right? And having a fungi that can dig down and break down things, especially break down toxic compounds, or maybe not break down toxic compounds, but break down things that are harder to break down, I think is going to be very revolutionary. And we'll start to see a major shift, I hope, where you'll go from this kind of plastics that can't be broken down to organisms that can maybe break them down for us.
I agree. Plant and fungi have a huge potential as a biomachinery, right? I see plant as a machine which has billions of years of evolutionary forces behind it, right? I used to work on one project where they were using plant as a biofactory to produce vaccine. I think there's so much potential to use them to obviously to feed the world, but also to heal the world too. So currently our biomanufacturing is relying on microbes, which is great, but plants can be used more smartly. But they are great machines.
They're great machines, but they're complex machines. So it's I think the major issue with them at the moment. Well, at least some species of plants that have 3 or 4 genomes. So it's difficult to do some of the biotech or engineering on them. I've loved the idea of thinking about all organisms kind of machines that can be programmed and changed.
I think biotech, biology has been more of a discovery field, right? I think now is time when we have quite a bit data points. I mean, I'm not going to say we understand everything. Biology is complex, but now we have some basic understanding. I think now is time to start moving towards the engineering work from discovery to engineering and make biology more programmable I think that's what Igem is doing in a way, right? Helping you to apply the engineering mind to biology. So you mentioned two potential in the bio revolution phase. One is plant, other you said fungi. I mean, fungi, you can use it as a food, you can use it as a biomaterial. And they say biomaterial is going to be huge. Just biomanufacturing is going to be a $2 trillion industry, according to one McKinsey's report, because 60% of physical goods can be manufactured biologically. So whether it's your fabric or construction material, so we can use all these small biological machines to produce things for us, but we need to apply a more engineering mind to the biological world to make that happen.
It's going to be exciting to see where it goes, because in the next 20, 30 years, that's why I'm so glad where we're at, and like what generation we were born into, because I think the future looks so interesting. And I can't wait to see what even the next generation after us thinks of and kind of comes up with when they have all these tools and are learning it in a much younger age and can just run with it at a much earlier time than, having to have that university backing behind you, but starting to learn it in like high school, or even just some of the things like one of the companies that's based on Lethbridge makes kits that can be utilized for middle schools and high schools to teach them the basics of molecular biology, which, is the kind of fundamentals you need for some of this biotech. And yeah, it's going to be great to see the next couple generations and where they take this all.
Biotech is going to be one of the most important thing you can teach. I mean, programming has been great for the last 10, 20 years, but I think next stage of revolution will come in the biotech industry. So biology will touch different areas of all the industries, at least most of the industries. Great. I can keep talking about the biotech and the impact and potential. I get excited like you. I want to hear your perspective on how the biotech life science is booming in the province of Alberta, because this state has been popular for oil and gas historically. And you talked about agriculture, and now I hear quite a bit about the emergence of explosion of new companies, life science companies. There is platform Calgary, and there are all types of support systems sponsored by government to create new generation of life science biotech companies. So I want to hear from you, like what is the current biotech scene there, and how do you think this region is growing as a life science hub?
It has started as that oil and gas province, and you definitely see a lot of incubators still geared towards that, but they're starting to let in more of the biotech companies as well, and like taking notice of what biotech can actually offer to even the oil and gas field. So you see it for like not just oil and gas, but also some of the other side of the coin, like environmental monitoring, as I mentioned, the agri-food industry and agriculture in general in southern Alberta. I think that's kind of the major focuses that Alberta would probably still have. Environment and agriculture, oil and gas are always going to be probably the big ones. Well, those are the other two, agriculture and environmental monitoring, will probably get bigger and bigger.
Right.
But oil and gas will always still be probably a big one for the next little while, at least while we make that transition. But Alberta is great for that. You have both in Edmonton and Calgary major incubators and kind of accelerator programs to help companies. Then there's other government programs like the one that Allos kind of started in, which was the Green STEM program, to help kind of fund startup companies, take a research project from a research lab to a commercialization with that kind of focus on clean tech. So I guess it kind of all falls together, right? Like the clean tech kind of hits the oil and gas, it hits the environmental monitoring, it hits agriculture, because all those things have some sort of tie to clean tech and green technology. So
right.
I think that's probably the big focus of our province at the moment.
Right.
And I hope it sticks that way going forward. But, it's a very interesting province that way.
No province can go without good bioeconomy strategy, right? So every province needs, or every country, I would say, need their good bioeconomy strategy, because you can generate trillions of dollars eventually if you do a good job, as we have more tools coming in, more affordable data, sequencing data. It's so like cheap, the lack of better term, like so
Yeah.
inexpensive to generate, right? So most of the biological data with more sophisticated tools, yeah, the cost to acquire this data is going down. And I think with more data, more understanding, we can produce really great, impactful bio companies. And this is a great industry to empower local community too.
I fully agree. And I think our province is doing a great job with it, having different, even organizations that help kind of coordinate and bring people together in different companies in the biotech sector together, like Bio Alberta has done that very well. And I think it's just only going to continue to grow and make the bioeconomy stronger.
Are you a member of Bio Alberta?
Yes, we are.
How Bio Alberta is playing a role supporting the community?
It brings together so many different biotech companies, and even ones like I hadn't heard of before, or ones that you would not even think of being like in the bio sector, and just bringing people together and making those connections much easier, so you can actually get that, ideas out there and kind of bounce ideas off other companies that are existing. That's how it's really helped us, as well as offering many other things, benefits to companies, such as webinars and conferences. A little bit of funding to help different aspects, like bringing on staff. Yeah, they offer many things. It's been a very great organization to be a part of.
I agree. We are also part of Bio Alberta, and I really see their commitment to empower the local bio community, support the local company, enable connections, and help them fill the gaps. So what advice would you give to aspiring bio entrepreneur doing their research project in university lab or for some other company? What advice would you give? How can they start their own company? What should be their approach? What they should know that you wished you know when you knew when you were starting the company?
That's a very good question. I think probably one of the most helpful things that anyone that's even thinking of going to entrepreneurial can do is, while you're like doing your graduate studies, take maybe a course either for like credit or not for, or for non-credit through the university that is in like the business field or like management field, just to kind of get that your foot in the water of some of the different terms and things that need to be looked out for. Because I think if I had a little bit more training in like kind of that market analysis or financial analysis, I think that would have helped us jump out the gates even faster. You can always bring on someone that knows that. That's probably the easiest way. But if you want to do it yourself, I think getting that, having a little understanding of it yourself, even if it's just a night class you take, would be very beneficial to anyone that's thinking of getting into the bio or into entrepreneurial, the entrepreneurial side in general. But for a biotech person, or if you have a solid background in science, having a little bit more in the marketing side can be very beneficial.
I think scientific knowledge is great, but if you cannot sell it, if you cannot influence people, convince people, it takes quite a bit of time. So marketing skills and basic understanding of business, at least to understand the common terminology. At least you have some basic high-level understanding about financial models and basic ABC of marketing, how to influence people, some commercial skills. That doesn't hurt. So it always helps.
I agree. Those are definitely the skills I wish I had before joining this company, but I'm glad I've learned them since then.
So thank you so much, Harland, for joining me.
Thank you.
Very interesting to learn more about your journey, Igem, and your technology. I really appreciate it. Talk to you soon. You will hear from me very soon.
Great. Awesome. Thank you. Thank you for having me.